Okay, let's look at this example, example 5.4. We have another inverting op amp, and we want to determine V naught or V output here in this specific circuit. Again, we see we have our non-inverting input is grounded, but now we have a voltage source connected to it. We have our inverting feedback resistance over here connected at node A to 40 kilo ohms, and then we have our input connected to our input resistance, which is also going to our inverting node. Okay, so we're going to apply KCL at node A. And if we do that, we get VA minus V output, so VA minus V output over 40 kilo ohms. VA minus V output, or V naught, over 40 kilo ohms is going to equal to the input here, which is 6 minus VA over 20 kilo ohms. 6 minus VA over 20 kilo ohms. Okay, we rearrange this equation. We get VA minus V naught or V output equals 12 minus 2VA. Simplify it some more. We get V naught equals 3VA minus 12. Okay, but like we mentioned before, we're assuming ideal op amp, so for an ideal op amp, VA is equal to VB, okay, and in this case we know that VB is 2 volts. Okay, so we're going to say, well, as VB is 2 volts, that means also VA is 2 volts. Okay, so we can plug this into here. We get V naught equals 6 minus 12, and that gives us minus 6 volts. Okay, and then, so that's our V naught here. Okay. One thing to notice is, if VB equals 0, which also will equal VA, then we just plug that back into the equation. V naught equals minus 12, and this is expected, as expected, from the inverting equation, as expected. Okay, so just a side thing here, and that's how you solve V naught for this problem.